What is up, everyone? This is your introduction to VexCode VR, virtual reality. We have some vocab words I gotta go over before we get started though. So Drivetrain is a robotic subsystem that allows a robot to be able to move. And there are two main ways in which these robots move. One is with wheels, such as the ones in the Clawbot over here, or tank treads, such as the one in the robot built over here. And every drivetrain has something called a chassis. And even though it looks like it's chassis. And that chassis looks like this, and it's the underbelly of any robot or car, and it's used for the wheels to be attached. It can also hold the motors or anything else. For example, in the Clawbot over here, the wheels are over here, and the motor is right behind the wheels. It attaches both the wheels and the motor. And just a quick note about chassis. You can build them in different ways, where, for example, this one over here has a wider chassis, which is going to affect the way in which it turns, whereas this one has a longer chassis. So think of turning left or right. Which one do you think is going to be able to turn more easily? By the way, you see how I used alignment to line these pictures up? Looks good. Throwback. Alright, so to figure out which one can turn more easily, it has to do with an idea called turning scrub. And the more turning scrub it has, the harder it is to turn. So this one over here, this longer one, has a higher turning scrub, so it's more difficult to turn, where this one has a lower turning scrub, making it easier for it to turn. So the shape of the chassis really has to do with how easily you want something to be able to turn. And think of the shape of cars. Car on the road can't just turn into a parking spot without having to move a great distance because it looks like this one. Whereas a car that would be wider like this, which isn't seen very often, is a lot more difficult to turn. It has more turning scrub, which basically means the friction that the wheel hits against the surface is higher, so it rubs more, which means it's harder. Friction meaning like against something. The same friction that happens when you rub your hands together and they get warm. I don't have my hands, so when it gets hot when you do that. Alright, so the way you're going to be using the drivetrain on VexCode VR, as soon as you get to the website, on the left-hand side, you'll see code, and you'll see a lot of different options of code that you can go through. The top one has to do with the drivetrain, which you now know what it is, which has to do with going forward, right, heading. You can set the speed. It has to do with the magnet on this robot. So if we were to open the playground, we would see our little robot here. Let's look at him in 3D with this button. Hey, make it bigger. So our virtual robot has wheels on the drivetrain, and the chassis is kind of a rectangle shape. You guys are going to have the chance to code him to complete different challenges. What's that, little buddy? Oh, he wants to tell you guys about his sensors. So there are a lot of different sensors for the Vex parts that we do in the classroom, but I'm only going to go over the ones the VR guy can do. So the first sensor is the motor encoder, and this is able to detect 360 degrees in the wheels, specifically the revolutions, the movement of those wheels. So imagine this Gatorade top was the wheel of the car. It's able to determine if the wheel has turned 90 degrees, 180 degrees, 270 degrees, or a full 360 where it's back to zero on top. This is really important. If you only want it to move a little bit, you can code it to only turn 90 degrees, which is like 1/4 of a movement of the wheel. So instead of saying to like a car, put your foot on the pedal for 3 seconds, you would tell the motor, which is encoded by the motor encoder, to move for a certain number of degrees. So under the drivetrain, when you go over to turn for degrees, that motor encoder is telling it how many degrees it is, just like the... So when I tell it to turn right for 90 degrees, let's take a look what would happen. But let's not do this in 2D, let's turn this into 3D mode. So we hit play, and we'll watch the robot move, and as it turns over here, what you should notice is that its rotation moved to 90. Keep your eye on the rotation right here. So when we play this over here, you'll notice that it's going to move, and its rotation is going to go all the way to 90, and the motor encoder is what's letting that happen. The second sensor is called the eye sensor. So this sensor right here allows this VR guy to draw a infrared line from here all the way to the end to detect the distance it is from the end, or at least the next closest object or wall. You'll notice as it moves, this is going to change. And it continues to change as it moves, as you can see over there. And the eye sensor can be found under sensing as the tab over here, all the stuff in blue. The eye sensor is responsible for all these commands, and you can see you can even determine using the front eye if it's close to an object or if it detects a color and lots of stuff. This sensor is especially helpful in a map like disk transport, where you have red disks over here, and you can use that sensor to determine when it is able to see one of those disks. And it can detect many different colors. One final thing about the eye sensor is there's actually two of them. This one faces forward, and this one faces down. You can see what they read up top, front eye, and down eye, and it can be used to help detect colors or objects if they're in front. The next sensor is called a gyrosensor. This thing is super important for allowing something to travel straight and make accurate turns. Imagine how tough it would be for the Mars Curiosity rover, which is on Mars, didn't have a gyrosensor, and it just fell into a crater, and all of that time and effort was lost. Like, being able to detect where and how many degrees you're turning, very important. So if I were to make it turn for 230 degrees, the sensor would over here show you the heading and rotation of it all the way to 230, and you notice it turns precise. You can even fix your turn where after that 230 degrees you want it facing a certain way, you can set it to that by turn to heading. So if you can see over here, it's going to turn. It's going to be turn to its 320 degrees, and then it auto turns back to 90 degrees over here. That would be important if we wanted to go that direction afterwards. Gyrosensor, very helpful. The second to last sensor is called the location sensor, and it has to do with the XY plane like the one over here. By the way, easy way to remember that, the y-axis, if you nod your head, yes, yes, up, down, like that. X, on the other hand, means no. So you say no like this, and that's the way of the X. So this sensor, it allows you to figure out on the map where you are. So when we are positioned over here on the map, it says our location x0, y, negative 800. So if we look at the whole grid over here, the origin is right here, and right now we're down 1, 2, 3, 4. So each block is worth 200 if you do the math. So if we wanted to go from here to the center, we would have to go forward for 800 millimeters. So we can go over to drive, and we can go forward for 800 millimeters. We would change the 200 to 800. And if I wanted to delete the stuff we had before, you can hold down on the code, and after holding down on it, it will say delete block, and you can delete the blocks by holding down. So now that it's going 800 millimeters, we can see that our little robot's going to go to the origin, the center over there. Hooray. By the way, the coordinates are measured by the middle over here. In other words, the pen's location. Which pen's nicer? Jokes! All right, and the final sensor is bumper sensor. So the bumper sensor can be found, there's two of them on the front of the VR robot over here, which looks like that and that. And this thing's basically a switch. When it's pressed, boop, it will read a value either on or off, 0 or 1. 0 means that it is not pressed, and 1 means that it is currently pressed. It will read false if it's a 0 or it's not pressed, and it will read true if it is pressed. So if we were to bump into a wall, both of those would read what? Yeah, true. And this is under sensing, the blue one, and you can see over here left bumper or right bumper. To use this, you would drag this left bumper into the diamond over here in the wait command. You connect to the edge to this, it will light up, and it will snap in place. So this blue thing is an example of something called a Boolean block, which is essentially something that waits for a true or false condition, where this is reporting true if the bumper gets hit or false if it's not currently pressed. You'll know it's a Boolean block whenever it's a hexagon. Hexagon, 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 hexagon. 6 sides, and those are Boolean blocks. They fit inside all of these control commands that have those hexagons for them to be put in. And this one's not really a sensor, but the last thing is the electromagnet, which is located over here below the gyrosensor right here. Basically, when the magnet is on, it can pick up one of the electromagnetic disks in the game Disk Transport. So when the robot is on top of one of these, you can turn the magnet on and collect it so you can move it. And you can find that by just clicking on magnet right here, and there's only one command, and you can boost it or not boost it. When picked up, it will look like this. You can pick something up or drop it like that. And you dropped it. And that is a full rundown of everything you need to know for VexCode VR. We're going to do a lot of challenges, and hopefully it's real fun for you guys. And I'm out!